Servo is an experimental web browser layout engine being developed by Mozilla Research for new generation hardware. The project has a symbiotic relationship with the Rust programming language in which it is being developed. Rust is a new programming language for developing reliable and efficient systems. We are working on implementing WebSockets. The WebSocket technology in web browsers is relatively new and addresses the lack of arbitrary TCP/UDP connections from JS in web pages. The protocol to connect to a server is well specified, as is the protocol to sending and receiving data. But the nature of data being sent or received is completely up to the web page and server. It's basically another form of TCP on top of TCP. Implementing this protocol and the means by which the web pages can use it will help expand server's capabilities and expose and latent architectural problems with regards to networking. We worked on Ubuntu Linux machine. We first installed the Rust compiler and some prerequisites like glfw package, etc. To build the servo, we cloned the repository using git clone. We built the servo using /macbuild command. Now we refactored servo according to our project requirements. As the first part of our project, we created two files. First, we have created the interface WebSocket, which inherits the event target interface. The next file is the corresponding implementation of WebSocket interface, which is the WebSocket.rs. We have created the struct for WebSocket with event target URL, state, and load response as attributes. We implemented the constructor for WebSocket, which takes URL response and state value as arguments, which creates a new WebSocket object. Now we start with the second part of the project. This diagram illustrates the steps to establish the WebSocket connection. Step 1. The load function of resource task is called with a sender as soon as an object of WebSocket is created. If it is WS type, that is WebSocket type, then the load function of resource task will call the load function of the WS loader. Step 3. After this, WS loader will call the load function of HTTP loader and it will receive a corresponding response from it. Step 4. The WS loader will check the response whether it has an upgrade field with attribute value WebSocket. If it exists, then it sends OK back to the WebSocket, which completes the WebSocket connection. Now we'll show you the files which we have changed. The first file is resourcetask.rs. We match the URL received to check for WS. If WS is present, then we call the factory of the WS loader. We added a new attribute stream to the load response struct. We added an additional argument of TCP stream in the start sending opt function so that we can receive TCP stream attribute from the response. Now we'll see the WS loader. The WS loader has a load function which creates a sender-receiver pair and calls the load function of HTTP loader by passing the new sender as one of the arguments. After receiving the response from the HTTP load, we check if the response has an upgrade attribute which is set to a value WebSocket. If such an upgrade attribute is present, an OK message is sent to the WebSocket object in the WebSocket.rs file, which completes the WebSocket connection. In WebSocket.rs, we added a response field of load response type to receive appropriate response from the load function of WS loader. We created a new sender-receiver pair. We call the load function in resource task with the new sender as a parameter. The response received from the receiver is used to initialize the WebSocket object. We also created a send function to send messages over the connection. In http:/loader file, we get the response reader using the read_response method. We extract the buffered stream from this response reader and then use the .wrapped to get network stream. We get TCP stream by cloning the normal stream variant. We send this TCP stream via the start sending opt method and set the attribute value of TCP stream in the load response struct. This TCP stream can be used by WebSocket object to close and open the connection. Thus, making these changes, we successfully established the WebSocket connection and completed the task.